we are discussing, now we are discussing about health services. In that, we are discussing about bioceramics, how bioceramics is made. Bioceramics are ceramic materials specially developed for use as medical and dental implants. They are usually used to replace hard tissue in the body like bone and teeth. Common bioceramics are alumina, zirconia, and a form of calcium phosphate known as hydroxyapatite. Next point is bioactive and bioinert. Bioactive ceramics interact with the body so that tissue bonding and eventual incorporation into the body occurs. After a time, calcium phosphate based bioceramics are bioactive. Bioinert ceramics don't interact with the body environment apart from causing an initial fibrous tissue reaction which coats the ceramics. Alumina and zirconia based ceramics are classed as bioinerts. Raw materials. Next point is raw materials. Alumina is a white powder. When shaped, compressed and heated to a high temperature, the ceramic that results has high density, high strength, excellent corrosion resistance, good biocompatibility and high water resistance. It can be machined, ground and polished to a high quality product. Next is zirconia is also a white powder. It can be compressed and sintered into a very strong ceramic by adding yttrium oxide and small amounts of magnesium oxide. A better wearing bioceramic called YTZP can be made. Next point is calcium phosphate or hydroxyapatite. Is the principal component of a natural bone in the body. Ceramics made from synthetic calcium phosphate can also be used in medical applications. The problem is that these ceramics are not as strong as alumina or zirconia ceramics. Next point is bioceramic bones and teeth. Alumina bioceramics are used as replacement parts in the hip and knee operations. The inertness of the ceramic, its high wear resistance and its excellent biocompatibility make it the ceramic of choice. The high load bearing properties of alumina also makes it an ideal ceramic for dental implants. Calcium phosphate ceramics can bond to bone and promote bone growth as their surfaces. A popular surface use of these ceramics is a coatings on dental and orthopedic implants. For example, titanium tooth root pegs coated with hydroxyapatite give a longer lasting implant that pegs that have been glued are cemented in place. The hydroxyapatite binds chemically with living bone because it is a bioactive ceramic. And next point is bovine hydroxyapatite. Often, as a result of injuries sustained in road crash accidents, bone reconstruction operations are needed. Material is heated to 1000 degrees C. After this heating process, what remains is an open 3D mineral shell of hydroxyapatite. HYDRO hydro, Oxia OXYAP, Oxiapa PATITE. Small cubes of this material can be grafted into the damaged living bone site over a period of time. New bone develops and grows in and around the implant. Successful repair of the damaged bone is achieved. This is the information regarding bioceramics, and it will be highly useful in dental implantations. But one thing I will say that this is the fundamental information regarding bioceramics. How bioceramics is made is the basic information. But if you want to do for sales and industrial purposes and medicinal purposes, if you want to learn all these bioceramics, it is better to get training. You are having a diploma in bioceramics, otherwise in related to that, and as well as you should get a training in under one person, senior persons, then you can start independently. So this is the information regarding bioceramics. Wishing you all the best.